All right, we are live. Welcome to our second code review performance roundtable. And without further ado, I'll get straight to the topics that we need to discuss. So we have a returning topic about streaming data to the front end, what changes could be required or could be done in the back end. And we have a pending thing that we were talking last week. What data do we store in Redis exactly? And is it structured or just a plain JSON string? And Patrick, you left a comment. Do you want to summarize it here for the call very quickly?
Yeah. I mean, we still cache or store something in Redis in diffs, but we remove like the serialized caching for the diffs endpoint and for discussions. So we're no longer storing them in Redis, but there's still some like for the list of merge requests and merge request diff by the REST API. So still stored in Redis, still cache them as serialized JSON, and some other stuff like the highlight cache and the stats cache, which is also related to diffs. So, and we also store them as JSON. So, yeah.
Right. So it is structured and okay. So why we moved away from moved into HTTP caching to relieve the load on Redis, I guess. Was that it?
Yep. Yeah, there was an need for the issue before. That's like because we're using a lot of Redis storage. So, and it's not really that being used that much. So started to remove it from Redis and utilize HTTP caching, which is just being okay.
Mm-hmm. Yeah. So last week we talked a little bit about some discussions going around with the concept of one app concept, and I shared the link on the agenda last week. The idea there is to even do a more aggressive client-side caching without not just relying on HTTP caching for the request, actually caching data on the front end in a structured database like in IndexedDB, and then using a service worker to control the way that we load the data and cache it and everything and check for the caches before requesting from the server. So that is something in the realm of possibility for us. So if we do, does that mean that so now instead of just storing the request response, we could be getting a little bit smarter on it. And so instead of just storing the batch, so for example, instead of storing the batch requests in the HTTP caching, we could just store the actual structure of the merge request into the code review, into the IndexedDB side of things in the browser. Any thoughts there? Any objections on it? Any concerns?
I think it makes sense. Go ahead.
Oh, sorry.
Go ahead,
I have the most relevant experience with this approach because yesterday I was fixing a bug which was caused by us having like an SPA like pages, which is merge request, overview page, and diffs page. So basically, it simulates SPA, and it has a lot of problems when you need to go from one page to another page. So maintaining that approach is actually quite hard on the front-end side because we have to basically code all the stuff the browser does for us. And it has to be really reliable because if it doesn't work, we are just out of luck. So working on that is actually tedious for the development team. So if it does make sense from the performance perspective, we should also consider if it outweighs the development costs and maintainership costs.
So when you say that, are you talking about caching on IndexedDB or?
No, I think Tim's proposal is two things at the same time. He wants to cache all the data and do an SPA-like behavior on the pages. So when you click on a link, it's instantly shown. Sure. So I think these things don't work separately, and he wants to combine them into one one single proposal, I would say. So doing the SPA stuff is really hard. So we have to seriously consider, is it worth the effort to put a lot of resources into that?
Okay. So again, that effort is a little bit wider than the code review, and it's definitely something for us to reach out and talk about. In the meantime, we'll take note here and we'll move on to the continuing discussion of this, because it's about the streaming of data. Thanks for that note. Patrick, you had a question on your comment. Patrick, you had a question on your comment that said, why do we need to change how we return data from the backend? And Stanislav, you have some thoughts there.
Yeah, the main problem with batched approach that we have right now is you might have 5 small files in a batch, or you can have 5 very large files in a batch. And this will seriously affect how soon we get the response from the backend, or how soon we can show these files to the user. So my idea in the next point was to actually get rid of batching completely for the files and just serve them like separately from each other, so we can fetch them in parallel, and that could be much more efficient for the users when we use streaming, because we can show files instantly as they're served instead of waiting for the whole batch. So that's right now that is not really a problem, because we don't use any kind of streaming or progressive rendering. It's all just plain show us the files and that's it. And with streaming, we have to consider a different approach, because it really depends on the data that we have. If we are slow on the data side, it won't really benefit us on the streaming side, because we'll still have to wait for like 3-4 seconds for the whole batch to be received. So that was my point.
Gotcha. Thanks.
Makes sense. Thanks for explaining.
And I'll build on top of that, and I'll say that when I raised this question, so one of the things we discussed in the past with the batching already is that when we're requesting the data in different requests, like Rails gets that request independently. So in essence, I'm not entirely sure how we do it on the backend. So that's why I'm asking this. Is we have this pipeline of fetching data from Gitly, storing it in the database, and then sending it to the browser. We also have that distinct behavior between a head comparison and different merge request versions comparison. Is that normalized already now? I don't think it is.
What do you mean by normalize?
So do they behave in the same way? Do we store the different merge request versions in the database, or when we request a different comparison, say from version 3 to version 7 of the merge request, we have to go to GitLib to get that at the moment?
Yeah, we still need to do that. Like, yeah, but we store every version database.
Okay.
But if we're comparing like different versions, we have to go to.
So we don't store them in the database. That comparison.
Yeah, that comparison.
Okay.
That cool. So that would be a lot if we need to store each comparison.
Right. That's reasonable. Yeah, that's reasonable. So the point then becomes, when we were requesting the first, so in the current day, we were requesting in pagination, right? We request the first page, the first page of files. And I'm already talking about batch diffs, not in the metadata. The first batch, and then we request a second, then we request the third. We can parallelize the request, but it's always paginated. And my fear is that, and it's always been, we discussed this in the past, that when we're requesting the first request, we still have to get the data, but we know for really large MRs that the next pagination is coming right after that. So I always wondered if we did this differently, if we rewrote this today, could we find a different approach? Like Stanislav is saying, like, we don't have to wait for the first file, if that's the largest, to start serving the second and the third. If you can just like start streaming it down the pipeline as soon as we get it, but I also don't know if that's even possible given the way we get the data from Gitaly. And last week we discussed briefly a suggestion that Kerry had done in the past, which was to precompile these data and store it somewhere. If not on Redis, some object store somewhere could be an option of like pre-calculating the data structure that we need for each MR version, and then store it somewhere, and we just be requesting the static data and just stream it as soon as we can. Yeah, so that was the question. We don't necessarily need to change, but we have the opportunity to maybe rethink the way we do it at this point, because we want to change approach on the front end, and that could give us some opportunity to change a few things how we do it on the back end. Does that make sense, Patrick?
Yeah, makes sense. Makes sense.
Okay. So, do you have any ideas of or how we can benefit, how we can change, or what would be done differently if we were starting now?
I think Stanislav's idea below regarding like we're going to like fetch diff for each file. I think that's possible. I think it's even possible right now. Like the diffs batch can accept a path. The diffs batch endpoint can accept a path. So if we have the list of files that we need to load, then we can have like, I don't know, multiple requests at once. And then whichever comes first gets streamed. But yeah, I'm not sure about like, I think the next what's called this, the next idea transport, like using WebSockets. I'm not sure about that yet.
Yeah, so maybe we can move there. And sorry, I just invoked Siri by accident. So we can move on to that discussion, and then that can probably fit into this. So the second question that was still open for the front end is, what's the ideal transport channel to get required information streamed from the backend? And just to give you a bit of background here, I'm being generically speaking because it's on purpose. So the options, there are several of them, with WebSockets, with GraphQL, with even gRPC. So what's the ideal way to deliver this data to the front end, given our past experience? And this is right up your alley. Stanislav, Thomas did leave a comment wondering if WebSockets would be a good option, but Stanislav, let us hear it.
I think it doesn't really matter which protocol we use. It doesn't matter if we use HTTP or WebSockets. We still have to wait for a single batch of file to actually show it. So we can't actually like partially receive half of the file and show half of the file rendered. We can't do that stuff because we have to wait for the whole stuff. So WebSockets, I don't think they will bring us any benefits to that. But what I'm mostly concerned about is caching. So if we can cache on an HTTP level, that would be really nice. That means no GraphQL, because GraphQL cannot be cached with HTTP. If it can be cached both on the Rails side and on the HTTP side, it will be also very nice. So my concerns here rely only around caching, and everything else is not really that important. So we can stick with simple HTTP requests, and that will be enough.
That's interesting. Wouldn't it be nice? So doing HTTP requests, we have to do basically almost individual requests per file, right? And that would leave us in the same position that we are today, where we have to wait for the first to finish. Well, we have to consume them in a sequence, right?
That's one of the downsides of WebSockets, because it has to stream the files sequentially. Mm-hmm. And with HTTP, we can actually fetch them all in parallel, just launch them as soon as we receive the metadata and launch this request. So it really doesn't benefit us in any ways, and HTTP is actually more beneficial when we do streaming.
Okay. And if we have an open discussion about that in one of the issues. I can't remember which one. One of my thoughts there is that is very much front end controlled, right? We control when we do that request. And I'm not sure if that matches when the backend is ready to give us that information. And I mean, what I mean by this is, like, if we could have a way to start, if you could have a way of the backend controlling, delivering us the information as soon as it could give us the opportunity of like pipelining in a way, or parallelizing the responses, where the front end will be handling them as soon as the backend is ready. And that is the idea behind the question. Do we have any solution? Do you have any solution in the market that could give us that? Whether the or is the backend even able to do this in a non-sequential way, or do we have to always get it from Gitly, always get it from the database or something, and always give us in a somewhat sequential way?
Yeah, that's what I was to say. Because if we're going to stick with the current order of the files
Sure.
right now, it's still going to be sequential, because if we get it from Gitly, whichever comes first will be processed first. But if we're going to change the order, like, we can display like the smallest one first. It may be possible, I'm not sure. Maybe on the database level it's possible, because we have the size of the diff
Sure.
of the diff file. But if we're going to fetch it from Gitly, I'm not sure.
Okay. Yeah, I maybe one of the discussions we can have in the future is drill down on pre-calculating those payloads. And we talked about this last week, where those payloads only change really when there's a change in the history, when somebody pushes a commit or pushes a rebase or something like that. Or if it's a head comparison, well, then that's constantly changing, because head is constantly moving. So is that even worth pursuing? Because of the head is the most common comparison we have. So the question is whether that will even stay accurate for long. Wait, we can have a discussion on that, just to validate on the future, because we have a couple of topics. Should we move on? We have a couple of topics today. Let's let that marinate a little bit. Thank you for that feedback, Patrick. So the same approach we have today could be used for streaming. We just have to optimize the way we get the data and that sort of thing. And let's think about this in the future. If you have any ideas, please bring it up in the issue. Okay.
Yeah, I have to confirm first though, the dispatch endpoint, if it really supports the path parameter that I mentioned earlier.
Okay.
So
I
probably post on the
wanted to add the last point to this. One of the problems right now is also related to metadata of the merge request, because not only we have large files, we also can have a lot of files changed. So it can be 200 files changed. So the metadata would grow significantly large depending on the amount of files you have. And my idea was also to enable pagination for the metadata, so we can start fetching the files sooner and do not relying on the size of the merge request. So that was another idea.
Any thoughts there, Patrick? Or should we just open it thread in the issue?
Like, what do you mean if we're going to paginate the diffs files and the metadata? Is that correct?
Yeah. The idea is to, instead of having one diffs metadata, the diffs metadata would also be paginated. Like, give us the first 100 files on the metadata. Beyond that, it'll be a larger page though, not just like 5 files or whatever it is on the batch diff. It will load a lot more, but still paginated. Is that an issue? Is that possible? Is that beneficial?
I think it's possible, because we already did it for diffs batch.
Sure.
So I mean, we're just going to get the same data. We're just representing them differently.
Yeah. So Stanislav, one of the homeworks for you is to open that thread in a new issue for the next week, so we can have people discuss it asynchronously, and we can kick the tires on it and see if it's worth scheduling an issue for start to work on it. Okay.
Yeah, sure.
Thank you. We have 6 minutes now to go through the next topics. So I'll blaze through a couple of them. So there was another returning topic. Carrie had talked about trimming the records on the merge request diff tables for outdated merge requests. There was a bit of a discussion there. And it culminated with Patrick asking, should we have this scheduled in the upcoming milestone, which is confirming the impact of deleting merge request diff commits records? I would say yes. It's worth the shot. Any reason we should not? I mean, the earlier we look into it, the better, right?
Yeah.
Okay.
That's why I'm asking if we can say. I mean, it's best our capacity, of course.
Yeah, I would say please ping Matt on it. Okay. See if we can start moving on that, because as we saw, it's something that it won't give us major performance boosts, but it's a application health perspective. So if the app is broken, then the app is not fast. All right, new topic. Thomas Randolph presented something. He's not here, so we can touch on it, but we won't delve too deep on it. We can bring it back next week when he's back. So his question is, can we deliver some or most or all the data we have as deltas or operational transformations, if I'm not mistaken? Yeah. And he goes a bit about that, and I shared some thoughts on it. And then Patrick, there was one idea to cache the diff on the client with an ID, and that was really an interesting comment. Patrick, do you want to bring it here in a quick summary?
Yeah, I think it's kind of related with the one app thing that you mentioned earlier, but I don't know, it's a bit simpler. My opinion. So it's like the idea is like if there's a key value store on the client on the browser, maybe a local storage or IndexedDB can be like on the first request for the diffs, the batch diffs, we can cache it. I mean, the front end can cache it, and because the diffs have a specific ID, so that can be used as the key. And then on subsequent requests, we can ask the backend, like, is this still the latest one? Is this still the latest diff ID? And check it. If it's not, make a new request, invalidate the cache it again. If there's no new one, then we just show the cache data. So we save like a backend request there.
Patrick, could that ID come straight from the server side rendered page, say that we don't have to fetch that ID from the server asynchronously? I'm guessing that ID should be pretty easy to cache in a very quick, meaningful way, like Redis, I'm saying.
I mean, it's just the ID, so we can get it from the database. And I don't know how the front end works. Like, I'm thinking we can like call this, display it as part of the HAML page. So and then
grab
like
it,
the data property, and then the front end can grab it.
Okay, so that makes sense. So we looked into this. So we'll continue to look this on the perspective, regardless of whether it's one app concept of SPA that Stanislav mentioned before, or it's just us leveraging it our own way for IndexedDB. And Thomas has a proof of concept from a year or so ago, where he tested that exact thing of caching things on the front end. We did have some questions about cache invalidation and privacy related stuff or security related stuff about people still having data in their browser of projects they don't have access to anymore. So there's a couple of questions in there that we want to like consider, at least in the way that we structure the data and how we store it. But that is a possibility, and I think it should be worth creating an issue. I know that you already have an issue for the fingerprinting of merge requests, getting a fingerprint ID thing, but there might be worth an issue for that particular idea of caching things on the client. So we can probably open an issue and discuss it there. Okay. Any more thoughts on that? We want to bring it back so that we can have Thomas discuss it on the next one, probably. So this will come back. especially about the deltas thing. There's probably something in there. What I said on my comment there was that comments are a great candidate for this, where if we have them cached, we can always say, just like you're talking about the merge request ID, we can always tell the server, hey, do you have any comments after this? And for you, Patrick, my question, would we be able to send comments that have been updated before using the updated at or something? Like give us all the comments that have a created at or an updated at larger than this date. Would that be possible?
Yes, it's possible because it's stored in the database, so we can filter that out.
Right. So what this idea would be is basically store all the comments from all the nodes in the merge request locally in the IndexedDB. And then when we're loading the page again, we immediately render those. We request the server, hey, do you have anything beyond this timestamp? And then if you have something, you send that down the pipeline, and we'd add new nodes, or we'd update nodes that have been updated since then. And then the front end would deal with that conflict or update that. So that's an idea to,
Makes sense.
yeah. I'll open another issue about an issue about the comments too. Okay. All right, we're at time. Do we have a hard cutoff, or should we go on for a little longer? A few minutes.
I'm okay.
Stanislav?
Yep.
Thank you. By the way, I'll open a thread whether we should make this call an hour, because the last week we also was pressed for time and we had to rush the last point. So I'll bring that up so we can have a discussion. So the next topic, Phil was bringing up the topic of syntax highlighting, and then Carrie brought up the question, when was the last time we did a breakdown of median timings for various parts of a slow request? And that was really an interesting comment. And Patrick, you said, I think we can start tracking durations of certain tasks being done in a single request so we can know which parts are the slowest and get actual metrics from production data. Then Gary asked, should we get an issue in open and on what we could track as project for possibly 15.8 or even earlier, I would say. So yeah, thoughts there, Patrick? It seems like a slam dunk, right? We should definitely take a look at it, right?
Yeah, I think so. Because I don't know, I think it's better to have like production metrics so we can talk about the actual behavior.
So help me understand this a little bit. Aren't we able to dissect the request and see what was the method that took the longest in any circumstance? Do we have to lay down something before we can do that? Or could we go to a batch diffs request and analyze what's the longest part of the task?
Yeah, we can use a flame graph for that, but it's very specific to like what method. So it's kind of hard sometimes, like, okay, is it really, what part of the request is this method being called? Like, is it part of serialization? Is it part of highlighting or getting from database or KDB or something?
Mm-hmm.
So it's like, if we have those specific sections and we have like metrics on how each part, like what's the duration of each part, then we can see like, okay, this is the one, and then we can dig into that deeper.
And just to understand this correctly, for us, so that could be an issue, that could be part of this issue, right? To try to get that. But my question then, are we able to do that without preparation work? That's I'm not sure if I understood that. Do we have to do, so for example, for metrics, if we want to track some metrics of events and stuff, we have to add them to, user timing APIs or something. Do we have to do something on the back end to do this flame chart method thing before we're able to extract that? Or is it something that is just a matter of going in there and using the tools we have already? Because then that will be two issues. One would be to add the preparation steps, and then one would be to gather the information on the flame chart.
Yeah, I think the flame graph thing, I don't know if it's enabled in production, but on your local machine, you can do that for requests. But if we're going to like track the certain duration for each part, we'll need to track that in Prometheus.
Okay.
then yeah, we can get it from Thanos. That's the Prometheus dashboard and adoption.
Okay. Definitely get an issue going, please. Create the issue in ping Matt for scheduling. And I'm gonna assign this to either you or Carrie. Either are fine to create the issue, right? Because you have the
Yes,
more
I agree,
information.
but
Okay.
I've just been carried.
Right. Cool. Thank you. So and then Phil brought another topic which like has the front end gotten too complex, which is something we discussed last week a little bit about. We want the front end to do less of, not more of, because we discussed this crazy idea of getting the Git output from Gitly and just dumping it on the front end. The front end, we just have a worker munching on it. And it's like, could it be done? Yes. Should it be done? No. So this led to something that I've been wondering for a while. Like we've talked about, we've been very additive in the way that we added to the batch diffs app over the past couple of years. And the question is, should we sit down and design the current system of all the parts that make generating the diff like a diagram to help us make sense of it all and potentially even get awareness of some things that we can improve? Does anybody see an objection or why we shouldn't spend time doing the diagram of this system? I'm not expecting it to be like a month or something, but I'm expecting it to be a bit of an investment of time to draw it. Any objections? Would it be useful?
I think for me, understanding how the front end works may help.
Okay.
Because I don't really understand it with them.
Okay.
I'm not sure what should we include in that diagram actually. Like
Okay.
we have a lot of small minor patches to the page to make it seem like it's very fast.
Mhm.
But if we collect all of them, I'm not sure if we will see like a bigger picture of what this merge request page is.
So this goes beyond the front end part. So in the front end, we have a bit of components, like we have, the diffs metadata. It stores, it traverses the information, creates the tree structure, and then has the batch diffs and puts that into the Vuex state. So that's how we deal with the rendering of the application. But then on the back end, we have Gitly we have information from Gitly, information from database, we have syntax highlighting, we have Redis. So we have a bunch of all these components that are playing together. And from the perspective of looking at it from above, we could potentially start to see that, hey, maybe we can move some things to the front end, some things could be pre-calculated a little bit. And I'm more about, we kind of have it in our heads, right? But having a diagram that can all collaborate and can all like update and keep it in our minds could probably yield. So like Patrick was saying, for them to understand how the front end is working with the data once we get it, might give them some ideas of, hey, we can pre-calculate that for you. That's what I'm aiming at. So I'm going to open an issue and then we can move that discussion there. My idea is to assign a front end and a back end to kind of work on this together, where one would be taking the design of the front end, the other would be taking the design of the diagram for the back end. But I'll open an issue and we can start there. We have two new topics. Stanislav, would you mind moving this to the next call? Because it's already late, and then we can move that to. You want to say something right now?
Since Patrick is here, I just want to discuss the last topic because he might be able to get us some information on this.
Right,
so basically, I've discovered that our overview page is rendered slowly because of the counter of the changes. It actually takes 30% of the whole page time. And I was wondering if we could cache it. So we just make it 30% faster. So
that's the number of files change, right?
Yep.
Yeah, right now I'm not sure why it's taking that much. 30%. Yeah.
Maybe there's a spike there. Investigate that particular delay to understand it and potentially cache it. What do you say?
Yeah, I think it's actually cache. Yeah, I'm thinking it's actually caching already, but
Okay.
I have to check. But do we have like a sample MR for this where it
Yeah.
shows that it takes 30%?
Yeah, I have. If you have locally GitLab shell repo, there is a merge request 7, which is like 170 files changed. If you open it up on the overview page, you will see like that the changes counter is really slow for some
So are
reason.
you, Stanislav, are you seeing this in local, the delay?
Yeah, seeing this locally, but I'm not sure how to check it on production because we don't have like performance bar, all the analytic
Okay.
stuff there.
No, might be that so the calculation might be expensive, but once we cache it, it might be fast. That's what I'm thinking. But okay, Patrick, could you investigate that? Your headset died. Okay, I mean, we're all about to be done anyway. Oh, he can't hear us. So, can you hear us? Is it coming from your speaker? No.
It doesn't have headphones. Oh,
Yeah,
Hello?
I know. Can you hear us?
Yeah, I can hear you now.
You're using the speaker. It happens.
Yeah.
So would it be worth investigation of the call and just to see what's happening, if there's anything that we can improve?
Yeah, I think we should investigate this.
Okay, spike for investigation. Could you create the issues, Stanislav?
Yeah, I'll go through all the issues that I've found out during the performance analysis of the merge request. And yes, since Patrick is in constant, yeah, I will assign it to
That
him.
was good. That was good. And what I was going to mention is, since this came off from this call, apply the label of the performance roundtables, okay? So that we can track all these issues in the same manner. And that's useful for scheduling and for planning, okay? Right. So we'll bring back some of the topics. So back next week. I'll move them to the issue once I create it, but this has been great. Thank you so much for the amazing session, both of you. My last thing would be to ask you, if you thought that this call was valuable, please leave a note in the agenda so that we can know that we should continue this call. I'll make sure that the recording is available on YouTube and ping the rest of the people to take a look at it. But thank you so much for the discussions. I'll look forward to seeing you next week, even if not on the call, at least synchronously on the issue. Fair?
Yep.